Have you ever looked up and wondered how a massive airplane stays in the sky? It's a question that has fascinated people for generations, inspiring dreams of flight and exploration. When you see a plane soaring overhead, it almost seems impossible that something so heavy could float above us, gliding effortlessly through the clouds. These metal giants, weighing hundreds of thousands of pounds, seem to defy gravity. Each time they leave the ground, it's a triumph of human engineering and imagination. The sight of a jet preparing for takeoff is a reminder of how far we've come in understanding the world around us. But it's not magic, it's science. The principles that allow airplanes to fly are rooted in physics, carefully studied and applied by generations of scientists and engineers. Every dial in the cockpit, every calculation, is part of a larger story about how we've learned to conquer the skies. Gravity pulls everything down, yet airplanes overcome it with a clever use of physics. The moment the wheels lift off the runway, a delicate balance of forces comes into play, allowing the plane to rise higher and higher. The engines roar, the plane speeds down the runway, and the wings interact with the rushing air. It's a symphony of power and precision, as the engines generate enough thrust to push the plane forward at incredible speeds. This creates an upward force that challenges gravity. The unique shape of the wings, called an airfoil, is designed to make air move faster over the top than underneath, creating lift. This lift is what allows the airplane to break free from the earth and climb into the sky. With enough speed and the right wing design, flight wins over gravity. The balance between lift, weight, thrust, and drag is what keeps the airplane aloft, soaring higher with every second. Understanding flight reveals the hidden rules of our universe. It shows us how invisible forces shape our world, and how we can harness them to achieve the extraordinary. With science and ingenuity, we've learned to soar across continents and oceans. Airplanes connect people, cultures, and ideas, shrinking the world and making the impossible possible. Let's dive into the amazing physics that makes these metal birds fly. Together, we'll uncover the secrets behind one of humanity's greatest achievements, defying gravity and taking to the skies. Flight is a delicate balance of four fundamental forces: gravity, lift, thrust, and drag. Each of these forces plays a unique and crucial role in the journey of an airplane through the sky, and understanding how they interact is key to understanding how flight is even possible. Gravity, the ever-present force, pulls the plane down toward the earth, anchoring it to the ground. But lift, generated by the specially shaped wings as air rushes over and under them, pushes the plane upward, working against gravity's pull. For a plane to rise off the runway and climb into the sky, the lift produced by its wings must be greater than the force of gravity pulling it down. This is why takeoff is such a dramatic moment. It's the instant when lift wins the battle. Once the airplane is airborne, lift and gravity reach a balance, allowing the plane to glide smoothly and maintain a steady altitude high above the ground. But moving forward is just as important. Thrust, created by powerful engines or spinning propellers, propels the plane ahead, slicing through the air and giving it the speed it needs to stay aloft. To keep moving, thrust must overcome drag, the invisible force of air resistance that tries to slow the plane down. The faster the plane goes, the more drag it encounters. Drag is a bit like sticking your hand out of a car window while driving fast. You can feel the air pushing back, resisting your movement. That's why airplane designers work hard to make planes as sleek and streamlined as possible, shaping every surface to cut through the air and reduce drag to a minimum. When the force of thrust matches the force of drag, the airplane cruises at a constant speed, neither speeding up nor slowing down, but gliding steadily through the sky. In essence, flight is a cosmic tug-of-war, lift battling gravity and thrust challenging drag. The outcome of this contest determines whether a plane soars, climbs, or descends. Pilots and engineers master these forces using skill and technology to keep planes flying safely and efficiently, no matter the conditions. And that's the secret behind every breathtaking takeoff, the perfect harmony of nature's forces, harnessed by human ingenuity. The secret to lift is the wing's shape, an airfoil. As the plane speeds up, air splits over and under the wing. The curved top makes air move faster above, creating lower pressure. Slower air below means higher pressure. This pressure difference pushes the wing up, creating lift. The faster the plane goes, the more lift is generated. That's why planes need a long runway to build up speed. Bernoulli's principle makes flight possible. How does a pilot steer a plane? It's a question that might seem simple, but the answer is more fascinating than you might expect. Unlike a car, which uses a steering wheel to turn left or right, airplanes rely on a set of specialized control surfaces to move in 3 dimensions. Not with a steering wheel, but with control surfaces, precisely engineered parts of the wings and tail that respond to the pilot's touch. Ailerons, located on the outer edges of each wing, are responsible for making the plane roll left or right. When a pilot moves the control stick, one aileron tilts upward while the other tilts downward, causing the airplane to bank and turn. Elevators found on the horizontal part of the tail control the pitch of the aircraft, whether the nose points up toward the sky or dips down toward the ground. This is how a plane climbs or descends. The rudder, attached to the vertical tail fin, manages yaw. By moving the rudder left or right, the pilot can swing the nose of the plane in either direction, helping to coordinate turns and keep the flight smooth. To roll the aircraft, one aileron rises while the other drops, tilting the wings and allowing the plane to bank gracefully through the air. Pulling back on the control stick raises the elevators, lifting the nose and sending the plane upward into a climb. Pushing the stick forward lowers the elevators, causing the nose to drop and the aircraft to descend smoothly. Pressing a rudder pedal with your foot swings the tail left or right, turning the plane's nose and helping to keep turns coordinated and balanced. By skillfully combining these controls, ailerons, elevators, and rudder, pilots can guide the plane through complex maneuvers, from gentle turns to steep banks, always keeping the flight path smooth and controlled. It's a precise 3-dimensional dance, sculpting the air itself and allowing the aircraft to move freely in any direction. That's how pilots expertly navigate from takeoff to landing, mastering the skies with every subtle movement of the controls. Birds were the first masters of flight, and we learned from them. Their wings use the same airfoil shape and principles as airplanes. Birds steer by twisting feathers and using their tails, just like ailerons, elevators, and rudders. Birds flap for thrust, planes use engines. This lets planes fly bigger, faster, and higher than any bird. The same physics, lift, drag, thrust, gravity, governs both sparrows and jumbo jets. Flight is proof of human curiosity and nature's genius. So keep looking up, who knows what we'll achieve next.